Okay, so let's talk about a combination you probably never expected to see: Bible stories and the area of a rectangle. Today, we're going to dive into a really fascinating math lesson that brings ancient scripture right into a sixth grade geometry class. Let's break down how this works. All right, so here's the deal. On one side, you've got your standard geometry class. On the other, you have the epic story of building Noah's Ark. The source material we're looking at today is a math curriculum that literally mashes these two worlds together to teach a single fundamental concept: how to calculate the area of a rectangle. Now, before we get to the Ark, the temple, and all that good stuff, we need to get grounded in the math that holds this all together. It's a formula I guarantee you already know, and it's the absolute key to everything that follows. And there it is. Simple, right? The area of a rectangle is just its length multiplied by its width. And the thing is, this formula is totally universal. It works for a sheet of paper, a football field, or, as we're about to see, a section of an ancient world-saving ark. Okay, so we've got the formula locked in our back pocket. Now for the fun part. Let's see how this lesson actually uses it. This is where things get really interesting, because the math gets applied to some very specific and very old stories. So the very first problem takes students way back, Book of Genesis back. The task is to imagine you're right there with Noah, laying down the wooden planks for a rectangular part of the ark's floor. The worksheet gives us the numbers to work with. The length of this section of floor is 30 feet, and the width is 10 feet. So how much space are we actually talking about here? And boom, there's our answer. We just use the formula 30 feet times 10 feet gives us an area of 300 square feet. You see? The math is straightforward, but now it's connected to this massive, epic story. Let's move on to the next example and see how this whole thing builds. This time, the setting shifts to the Tabernacle. That's the portable sanctuary from the book of Exodus. The problem here is about putting down a piece of fabric for the flooring. So for this secret tent, we get a completely new set of dimensions. This piece of fabric is 25 feet long and 12 feet wide. The numbers are different, so let's see what happens when we do the math. And would you look at that? 25 times 12 is 300 square feet. It's the exact same area as that piece of the floor on Noah's Ark. Now, this is a really clever way to show students that you can have two completely different-looking rectangles that take up the exact same amount of space. Okay, for the third and final example, the lesson really scales things up. We're not on an ark or in a tent anymore. Nope. We are heading to the grand courtyard of King Solomon's temple in Jerusalem. Here, the job is to find the area of a huge stone platform, and the dimensions are much bigger to match. We're talking 40 feet in length by 15 feet in width. So we run the numbers: 40 times 15, that gives us 600 square feet. And this just perfectly demonstrates how that same simple formula applies no matter the scale, from a small bit of flooring to a massive temple courtyard. So we've seen the what and the how, but I'm sure you're asking the big question. Why? Why frame a math lesson like this in the first place? What's the goal? Well, believe it or not, the source material tells us directly. The lesson plan calls this its big idea. It says, quote, "Math is part of God's order and wisdom for our world." So you see, the goal here isn't just about teaching math. It's about connecting the logic and order of geometry to a theological idea, framing math as a piece of an ordered, intelligently designed universe. But the lesson doesn't just stop with a big philosophical idea. It makes sure students really get their hands dirty and apply the concept, thanks to a pretty smart homework assignment. The homework is basically this 4-step process to make sure they really get it. It starts with a simple calculation, but then they have to get creative. After that, they have to work backwards on a problem, and finally, they have to step back and reflect on how it all applies to the real world. And if you look at the details here, you can really see how deep this assignment goes. Students go from a basic calculation for, say, a storage room, to inventing their own Bible-themed area problem. They're also asked to find a missing side if they're given the area, convert between units, and then reflect on why geometry is even useful at all. So in the end, a lesson like this proves it's about more than just length times width. It brings up a much bigger question, really. While the math itself is universal, the stories we choose to teach it with can completely change what is actually being learned. It really makes you think, how does the story we tell change the lesson we learn?